Welcome to my screencast on magnetism and magnetic fields. I have a Bard magnet here on the screen, and I'm going to click on Show Field, and you can see the field lines that surround the bar magnet. Now these field lines are shown by little miniature compasses, so I can put a compass on here and move that around the screen, and you can see that that also shows the field lines in the direction that the magnetism is related, the north being attracted to the south. Um, the other interesting thing about this is that you can see that it's brighter closer to the magnet and darker farther away. And that tells us that the closer you are to a magnet, the stronger that magnetic force is. And the farther away you are from the magnet, the weaker the magnetic force is. Now if we look inside the magnet, you can see that there's also a magnetic field inside, and this represents the electrons that are spinning and aligned up inside the magnet, which gives the magnet its magnetism. We can flip the polarity and everything just flips, including the compass. Now this is a permanent magnet that's just how they come, or we can actually look at a way to make a magnetic field, and we do this by using a solenoid. Now this is just a coil of wire attached to some kind of voltage source. Now before I go into detail on this, I'd like to show you that the difference between DC and AC real quick. So direct current is when the electrons are flowing in one direction through that loop, or through that circuit. And if I switch to alternating current, you can see that the electrons are reversing their direction forward and backward, over and over again. And we're going to come back to that a little bit later in this unit. So back to our direct current. Notice that we have the bright signs of magnetism up close, and it gets weaker as we get farther away, just like in the bar magnet. And we also have a north and a south, just like in the bar magnet. Now I can flip my battery and it also flips the magnet, just like when we were flipping, or the magnetic field, just like when we were flipping the bar magnet earlier. But in this case, we can actually turn off our magnetic field, which is kind of convenient in many circumstances. The other thing we can do with this solenoid is we can change the strength of our magnetic field by changing the voltage on the battery or changing the number of loops. You can see that it's getting brighter, and that just means that there's more magnetism. So thank you for watching my screencast on magnetic fields.